So for the rest of chapter 6, we're going to look at optimization. So trying to find the best possible solution for our system of linear inequalities. So we will have to create that system and then solve it. So let's take a look at our first example here. A refinery produces oil and gas. So let X equal oil and Y equal gas. So we've declared some variables because it's a real life problem. X is greater than or equal to 0. Y is greater than or equal to 0. X is an element of the reals because we can have partial liters. Y is also an element of the reals. So at least 2 liters of gasoline is produced for every liter of heating oil. So our first equation, at least 2 liters of gasoline. So Y is going to be greater than or equal to 2x. So we have to multiply the amount of oil that we get by 2. And that's going to be less than or equal to the amount of gas that we produce. The refinery can produce up to 9 million liters of heating oil. So oil, it will be less than or equal to 9 million. And for this question, we'll just write down 9. We'll leave the millions out for now. And 6 million liters of gasoline each day. So there's 2 and 3. So we have 3 different equations that we're going to have to graph. The company needs to determine the daily combination of gas and heating oil that must be produced to maximize revenue. So we're given a price per liter. So we are looking at revenue is equal to gasoline is $1.1 per liter. That was Y. And heating oil was $1.75 a liter. So first we're going to graph our 3 different equations. And each square will be 1 million. And we said that X has to be less than or equal to 9. So grab our ruler. And it's a solid line. We also know that Y is less than, right, we shade. X is less than, or Y is less than 6. Shade that. And last but not least, our first equation, Y is greater than 2x. So we know our X and Y intercepts are going to be 0 in this case. The slope is 2. Now we have to take a test point to see which side of that's going to be shaded. We'll take 1, 1. We'll check our test point over here. and we plug in 1 and 1 for x and y, and we get 1 is greater than or equal to 2. This is not the case, so we shade in that area there. Now, when we look at our graph, we have 3 points, right, for our solution space. Our solution space is a triangle, so we've got 3 vertices for that triangle. We want to figure out which one of those vertices will be our maximum solution. Now, by inspection, I know it's not going to be 0, 0, because you're not making any money. My money is on that spot right there. So let's try that. That spot is at 3, 6. So at 3, 6, our revenue will be 1.1 times 6 million. And X will be 3 million. And we do the math there, and we should get our answer. In this case, we can pretty much be guaranteed that that's going to be our maximum solution. In other examples, we may actually have to check all of the 3 points, but for our intents and purposes, we know that 3, 6 will be our best solution. So they are making, I am making math mistakes. I'm making a lot of money. I don't have a calculator handy. My phone is my recording device, so you can figure that one out. And that will be the maximum revenue.